What's going on, guys? In today's video, I'm going to be talking a little bit about data types and how they matter. I'm using the MoTeC C-Series Dash as a good example here because there's a circumstance where I had that I don't want people to fall into the trap on. There's data types that are commonly used in the background of basically all information systems. There's a way that numbers are presented with computers. Most of those data types are already pretty much predefined. There, you can get some very obscure types that get a little bit deeper, but ultimately they're broken down into like bytes and multiple bytes in some regards. There's a few options there, but today I'm just going to talk about 16-bit and 32-bit signed and unsigned integers. Here on the screen here, you can see that I have 16-bit, basically the minimum values you can hold and the maximum values you can hold for these data types, right? 16 unsigned values can hold a minimum value of 0, and they hold a maximum value of however many bits there are flipped, times in the binary sense. So like a 16-bit value can hold a maximum, 16-bit unsigned integer can hold a maximum value of 65,535. 32-bit can hold like 4 billion, 2 million, 200 million, something like that. So and then on the signed integers, essentially one bit is defined for the signage type, right? So you essentially cut your scaling in half, and half of it will be negative and half of it will be positive for signed integers compared to the unsigned counterpart. So a signed integer can have a maximum value of 32,767, which is roughly half of the 65,535 that the unsigned integer holds. Same thing for the 32-bit signed integer versus unsigned. But half of the value gets to scale, it gets shifted, essentially halfway, so it's in the middle. So your medium value is 0. Your middle value is halfway between 0 and the maximum on unsigned. It is 0 as your middle range value unsigned. I was having an issue with device uptime, and it was kind of blowing my mind a little bit, but I had to figure out what data type it's back in casted in order to understand the control mechanisms. And I just went and set up basically a test rig and said, okay, well, if I'm going to figure out what this is, how am I going to do it, and things like that. So what essentially I did is I went and and made a user condition, right? So I set a user condition up for device uptime sub 5 seconds, and I call that device uptime sub 5. And then I went and created another timer as well to be like, hey, like device uptime active timer. So when that condition is true, we're going to run a timer, and when that condition is false, we're going to essentially not, or turn the timer back to 0. And then I just ran it, right? And then I'll just go to online and monitor channels. We can see that it's currently active. I'm going to go ahead and restart. I'll disable and restart. I'll have to reconnect. And you can see that we're currently on. So and then it goes back in 5 seconds. We are over the 5-second value, so it goes to 0. And then as we go running, I'll just have to let it run for a little bit. But I had it where it was like this triggering issue, and I couldn't really understand why. So this is how I figured out what we need to do in order to solve a conceivable issue associated with rollovers, so to speak. Rollovers happen for just about any data type if you exceed the value at overflow. You can see that after 32 seconds, we go back to 1, and now it's going to count. And we're going to count for a certain amount of time. I know the timer's supposed to be 5 seconds, and it's not 5 seconds. We're certainly seeing it go higher than 5 seconds right now. So I was like, okay, what is this this magic that's happening on the back end that's causing this thing to engage? And essentially, we've probably got maybe another 10 seconds to go. So 32 seconds, 33, 34, 35, 36, 37. We got 37 seconds. Okay, so we had a value of 37 seconds defined. We had first initially 5, then 37, and if we let it run again. So, and it started and initialized at 32 seconds, 32.xxx seconds. Well, if we look real closely, we can see that our maximum value here is 32.767. And our timer, device uptime, has 3 decimal places. So what I could, I guess, corroborate with the information or infer from the information, the device uptime is essentially typecasted as an original stated integer. It's a 16-bit signed integer value that is typecasted to potentially, I'm not going to let it run long enough, but essentially, hopefully a 32-bit unsigned integer, because you shouldn't have a negative value for device uptime. So what I had to do is essentially set up another counter, right? And set up another timer to say, hey, we're just going to run this timer when the dash is on. And essentially set it up with a 0.1 resolution. So essentially timers, device active timer, we can add a new one. And you could say, we'll just say GP time, or you could set a new channel, but essentially set this timer to where, like, if your resolution, because the resolution defines how big this value can hold. So if the resolution's like 0.00001, we're only going to get, like, you know, not even a third of a second, so to speak. But if you set the timer as 1, we'll get like 32,000 seconds conceivable if it is a assigned 16-bit value. If it's a 32-bit value, it goes even further. But essentially my answer to this problem is to set up a timer, set the timer resolution to a value that I knew that he wouldn't exceed, because I don't think he's going to run the car for more than 27 hours at a time. And I was fine. And that was how I solved this problem. But things like these are, you got to understand if you're trying to troubleshoot or back end debug, what's going on the back end. This is the way to do it. And this is kind of how you need to think things out when you're troubleshooting things that don't make sense. Overflows exist. They can happen on any, basically if you overflow of any data type, it's going to roll it back over. That's just the way that the systems are designed to work. It doesn't matter what system you get. That is how they operate. They're only looking at a specific set of bits. They're only capable of looking at a specific set of bits to extrapolate a value from. So hope this helps somebody. If you're ever having an issue, device uptime. If you're going to use device uptime, I don't recommend it. Set your own timer. Use your own timer with an appropriate resolution for you, and you utilize that value if you're trying to do something where you're doing something when the car's on, or after a certain amount of time that the dash has been on and something hasn't happened, to set a condition, set an alarm, things like that. Hope this helps. If you have any questions, feel free to reach out, and we'll see you in the next video.